Good afternoon. I am Kalpana Madhushani from University of Kelaniya. My research topic is evaluation of antioxidant activity of Typha angustifolia. First, I would like to draw your attention into a brief introduction. Typha angustifolia is a member of family Typhaceae and the genus Typha. In Sri Lanka, it is locally known as hambupan. It is an erect, rhizomatous perennial aquatic herb, mostly found in freshwater habitats. Additionally, it is considered as a nuisance plant in Sri Lanka. According to the National Invasive Alien Plant List, it was recorded in the 6th place. Recent observations reveal the expansion of Typha angustifolia distribution in some dry zone areas of the country, increasing its extent into invasive proportions. Nevertheless, you may wonder if I say this invasive macrophyte has beneficial health effects. Yes, it is. For instance, in traditional medicine of China and among the Native American, it was considered as a valuable herbal remedy. It is also considered as a medicinal plant in Sri Lanka, even though the literature on herbal activities are scarce. Most common medicinal properties of Typha angustifolia are analgesic effect, anticoagulant effect, antiseptic effect, and homeostatic effect. Hence, these studies aim to evaluate the antioxidant activity of Typha angustifolia, different plant parts, as the extensive studies in biological activities of the overall plant parts are understudied. Let's move on to the methodology of the study. Here we studied two bioassays, namely DPPH and ABTS, for evaluate the radical scavenging activity of Typha. 3 solvents with different polarities were used for extraction. They are hexane, methanol, and aqueous extracts. 4 plant parts were used for the extraction covering the whole plant. They are leaf, leaf base, rhizome, and pollen. BHT and ascorbic acid were used as the standards to compare the antioxidant activity of plant parts. This is the extraction process. First, the plant materials are cleaned and dried. Then they were powdered. Powdered materials were extracted with different solvent using solvent extraction method. Then the solvents were evaporated using the rotary evaporator. Remaining excess solvents were evaporated using vacuum oven. Then the DPPH and ABTS assays were conducted to crude samples. In DPPH assay, samples were mixed with DPPH and incubated for 15 minutes in dark. Then the absorbance were measured at 517 nanometers using microplate reader. In ABTS assay, samples and standards were mixed with ABTS and incubated in dark for 7 minutes. Then the absorbance were measured at 734 nanometers using microplate reader. The percentage inhibition was calculated using the given equation. IC50 values of each extracts were calculated using the GraphPad Prism software. Now, I would like to present the results of the experiments. This graph shows the percentage inhibition versus the concentration resulted from DPPH assay of methanol extracts of plant samples and standard BHT. Here you can see that leaf base and rhizome samples show similar activity compared to BHT. This table shows the calculated IC50 values for above samples and BHT. Here we can clearly imply that leaf base and rhizome samples have lower IC50 values than BHT. Hence, those samples present higher activity than BHT. According to the results, BHT has IC50 value of 119.3, while rhizome has 65.3 and leaf base has 99.5 respectively. From all the tested samples, rhizomes showed the highest activity than others. This graph shows the total antioxidant activity of hexane extract of Typha plant parts in ABTS assay compared with positive control PhD. The antioxidant activity increases in a concentration dependent manner compared to BHD. The table shows calculated IC50 values. The comparison of the IC50 values of the Typha plant parts to BHD results shows the test samples show higher values than BHD. However, edible plants, namely leaf base and rhizomes, show comparable activity. This graph shows the activity of methanol extracts. As well as in the previous results, this also represents a similar pattern. The antioxidant activity of methanol extracts increase in a concentration dependent manner. Even though the IC50 values are higher than the standard, rhizome and leaf base samples shows comparable activity. This is the graph of ABTS radical scavenging activity of aqueous samples versus the standard ascorbic acid. But the all samples showed higher IC50 values than the standard. In conclusion, leaf base and rhizome of Typha angustifolia showed higher activity in some cases than standard. Moreover, the antioxidant activity was recorded in edible parts. Therefore, Typha angustifolia can be considered as a source for novel bioactive compounds to combat free radicals. Consequently, it can propose as antioxidant-rich food source. Finally, the extensive distribution of Typha can also be managed through the utilization of plant parts with these special capabilities. These are my references. We acknowledge National Science Foundation of Sri Lanka for funding this project. Thank you.